Hello everyone. I think you all have gone through the couple of lectures that I have uploaded earlier. Before watching this video, you have to go through the last lecture which I have uploaded on last Monday, because this is the second part of the same chapter. This second chapter is little bit long, that's why I thought to put it as two parts. In the first part of this, I have discussed about the format of algorithm writing according to the pseudocode method, naming conventions, explicit and implicit data definition, data types, constants, variables, global and local data, which are the main things about that we want to know about algorithm writing. And here mainly I am going to talk about the control structures which can be used in the algorithm writing. Mainly there are three types of operators. First one is arithmetic, second one is relational, and third one is logical. In the last lecture I have talked about the arithmetic operators, and now in here we will see what are the relational operators. Relational operators are symbols that perform operations on data and return a result as true or false depending on the comparison conditions. And some of these operators are used to express the conditions in algorithms or program statements. Here I have given operator name and the symbol of the relational operators. And also we can call these operators as comparison operators because we are using them to compare statements. And the first one is greater than, then less than, equals to, not equals to, greater than or equal to, and less than or equal to. And you can see the symbols that we are using to write algorithms in here. I will explain some examples in middle of this lecture, the use of relational operators with the control structures. Then logical operators. Logical operators perform Boolean operations on data and return Boolean results. It means true or false depending upon the statement's condition. These operators are useful if we want to combine several conditions into a single statement. For example, think we want to choose the numbers from a number set which are greater than 10 and less than 100 using a computer program. First, we need to design an algorithm for that. In there, we can use the relational operators greater than and less than to choose the numbers between greater than 10 and less than 100. And we want to combine those two conditions together. So we are using the logical operator AND for that. Like that, I will discuss some examples with the conditional structures later. In here mainly we have 5 logical operators: AND, OR, NOT, equal and not equal. And those things are about the logical operators. In the arithmetic or relational or logical operators, we can use brackets for prioritizing the calculations. It means before we execute an statement or expression, we need to know the order in which the operations are done. I think you all know about that order of precedence. First brackets, then power, then division and multiplication, finally addition and subtraction. Then arithmetic operators must be evaluated first, then relational operators, and finally logical operators, because all logical operators have prioritized lower than arithmetic and relational. Those are the main things you want to know about operators. Now we will see how to use them in the algorithms. Control structures. In general, a program is executed statement by statement from top to bottom without skipping any statement. This is known as the sequential execution. Sometimes this approach is not acceptable. For example, we may want to execute only some of the statements or to execute the same instruction several times. like that. In order to achieve this, programming languages provide special statements known as the control statements, or otherwise we can say control structures. Control structure is a set of statements which allows the programmer to specify the flow of the program control. That means the order which the statements are executed. And mainly there are three types of control structures. First one is sequence structure, second one is selection structure, and the third one is repetition structure. Now let's see what are those in detail. The first one is sequence structures. As I already mentioned, sequence structures statements are executed statement by statement from top to bottom without skipping any statements. You can see the structure in the slide. First go through the statement 1, then statement 2, after that statement 3, then statement 4, like that. Executed statements without skipping any of that. Normally all algorithm procedure and programs are executing like this. Think we want to execute some of the instructions only, not all. We want to execute statement 2 or statement 3 under some condition. For example, if the number is got from the user is equal to 3, we want to execute the statement 2, otherwise statement 3, not both. How can we do that? We have selection structures to fulfill that. Selection statements are used to select one option from set of alternatives. In real life, what are the selection options that we have? The first option is we can select or otherwise we can reject. The second option is we can select one out of two options. And third option is we can select one out of many available options, right? Like that in programming, here also we have the same three options. The first one is select or reject of any available options, or otherwise we can call it as if statements. And the second one is select one out of two available options, or otherwise we can call it as if else statements. Then the last one is select one out of many available options. We have three types for that in here. First one is nested if statements, or we can use if else if statements, or otherwise case statements. And these all are conditional statements. Conditional statements means according to the conditions program flow is happening. Now we will see each of the selection statements one by one in detail. First one is if statements. In here, statements are executed only the condition is evaluated to be true. Otherwise, this if block will not executed. Then that statement will not run if the condition is not satisfied. Here I have given the general format for pseudocode writing. First we have to write the keyword if, then the condition that must be satisfied within the brackets, then the then keyword. After that the calculations or procedures that we want to run if the condition is true. Then we want to write end keyword with if to indicate that we have finished the writing of if conditions. And in here I have given two examples for the if statements. First one, we want to print past if the mark is greater than or equals to 60. For that, like the general format, we can write if in the brackets the condition mark is greater than or equal to 60, then keyword, the next line printed past, then end the if condition. This block of code will execute if only the mark is greater than or equals to 60. Otherwise, this will skip from the procedure. Then the second example, if the total cost is greater than or equals to 100, we have to calculate the discount percentage as 10. So first if keyword, then the condition total cost is greater than or equal to 100 in the brackets, then keyword, next line discount percentage is equal to 10, then end the if condition. I think you all have got an idea how to include if conditions under procedure. Now think, according to the first example, what will happen? The mark is 40. And according to the second example, what will happen if the total cost is 50? To prevent that kind of problems, we are using if-else statements. This statement is also executed only if the condition is evaluated to be true. But in here, if the condition is not satisfied, then if statement will be skipped and else statement will be executed. If-else statements allows us to define an instruction which will be performed if the given condition is false. Here I have given the general format for pseudocode writing. Like as the if statements, in first if condition, after that then keyword. In the next line we have to give the statements to be evaluated if the condition is true. Then in the next line else keyword. After that next line we have to give the statements to be evaluated if the condition is not true. And then next line we can conclude the if-else by end if keyword. The only difference between earlier if statements and this if-else statement is the else part. Then let's see an example for if-else selection structure. In here, the example, we want to print passed if the mark is greater than or equal to 60. Otherwise, we want to print failed. So, according to the general format, first keyword if, in the brackets the condition mark is greater than or equal to 60. Then keyword, next line, what we want to do if the condition is true, print passed. Then next line keyword else. After that next line what we want to do if the condition is false, print failed. And finally end the if-else statements by end if. Okay, you all have got an idea about if statements and if-else statements, when and how to use them. Now we will move to the nested if statements. Nested if-else statement means the if-else statement inside another if statements. Here I have given the format for nested if-else for pseudocode algorithms. After the if condition in outer if-else, we can put another if-else inside it. If-else structure is same as the earlier. Now we will see an example for nested if-else statements. Here I have written a block of pseudocode for voting. If the user is Sri Lankan and age is greater than or equal to 18, user can vote. Then we have to check if the user is Sri Lankan or not first. If Sri Lankan, only we have to consider about the age. If he is not Sri Lankan, we don't want to consider about the age. Directly we can say he cannot vote. If he is Sri Lankan, again we have to check the age. If the age is greater than or equal to 18, then he can vote, otherwise cannot. In outer if condition, I have checked that he is Sri Lankan or not. So nationality must be equal to Sri Lankan. Here I have used two equal marks to check the equality. That's a relational operator. What happens if I give one equal sign in there? One equal sign is an assigning operator. Sri Lankan will assign to nationality variable. It will not check the equality. Don't confuse about those two. One equal sign for assign and two equal signs for check equality, right? Okay. Then if that the Sri Lankan condition is true, inside of that again we have to check the age. Then another if else have placed in there. If age is greater than or equal to 18, what must be equal to true? Yes, what must be equal to false? That inner if statements must be over by end if. Then else of outer if condition, what must be false? Because if the user is not Sri Lankan, he cannot vote. Then end if statements by end if keyword. This is a simple example for nested if else. Now think, if we can put those both conditions together, the nationality must be Sri Lankan and age is greater than or equal to 18 inside one bracket with and keyword. If you remember, and is a logical operator I mentioned in the beginning of the lecture, then it will simplify the if conditions. We don't want to use nested if else, just we want to write one if else statement, right? So we can use logical operators to combine multiple conditions together. Here we will discuss only logical operators and or. Other operators also can use in the same manner. First we will see about AND operator. If we join two conditions inside if condition inside the brackets using AND operator, the statements inside that if condition will execute it when both conditions are evaluated to be true. If one or both conditions are false, else statement will be executed. In here I have given the same example that we discussed in the nested if else. If nationality is Sri Lankan and age is greater than or equal to 18, what is true? So inside the brackets in the if condition we have to check nationality equals to Sri Lankan and age is greater than or equal to 18. If the both conditions are true only, what is equal to be true? If one or both conditions are false, it goes to the else part. What is equal to false? And finish the statement by end if keyword. You can see this is simple than the nested if else, but in the both codes doing the same thing, no difference. That's why I told in the beginning of this chapter, we can write different algorithms to accomplish the same task. Now we will see about OR operator. If we use OR operator to combine two conditions inside if condition, the statement inside that only be executed when at least one condition is true or both is true. It means one of the condition is evaluated to be true is enough for execute the statements under the if condition. Here I have given a simple example. We need to write a block of algorithm to indicate that the president or prime minister can approve the budget. So inside the if condition in brackets we can write position equal to president or position equal to prime minister, then budget is equal to true, else budget is equal to false. Finally end the if statement by end if keyword. If the position is equal to president is true or position is equal to prime minister is true, only statements under if is executed. If the both conditions are false only, it goes to the else part. Like that, we can implement other logical operators also in the same manner. Next, we will see about if-else if statements. To avoid deep indentations in nested if-else statements, if-else if statements are introduced. What is indentation? I think you all have noticed that when I am writing the if-else, I put some space in the second line front before I write the statements. Else part also like that. It is for improve the readability mainly. Such that in nested if-else, if we are going to put if-else conditions inside of 2 or 3 if conditions, it will hard to write and read. For avoiding that, we are using if-else if statements. In here, conditions are checked from top to bottom. Whenever a condition is evaluated to be true, the statement under that if is executed and rest of the conditions are ignored. It means if one condition is true, it will not check the other conditions and execute that only. If all the conditions are false, the last else statement is executed. Now we will see the general format for pseudocode algorithms. First, if and the condition to be true, and then keyword. After that, the statement that won't be executed if condition is true. Then else if, that the first condition is not true, we have to check this. Like that, we can add several else if, and finally we can put else and the statement to be evaluated if all else if conditions are false. Then end the statement by end if. This is a simple example for if-else if structure. We have to write a block of algorithm to give the grades according to the marks. If the mark is greater than or equal to 90, we have to give A grade. If it is between 90 and 80, B grade. 80 and 70, C grade. 70 and 60, D grade. And if mark is lower than 60, F grade. Like the algorithm in the slide, if mark is greater than or equal to 90, then grade is equal to A. Then we can use the else if. If mark is greater than or equal to 90, mark is not greater than or equal to 90, and if it is greater than or equal to 80, grade is B. Like that, grade C and D we can use else if. Finally, if all of above conditions are false, the default condition is grade is equal to F and this condition. I think you all have got the idea behind the if-else if. Next, case statements. Case statements also used for the same purpose that we are using nested if and if-else if. Select one out of many available options. The speciality in here is we can use only the set of options that available in here is the same type. For example, months of year, it means we can choose one month between January, February, March and etc. Then type of employees like temporary, permanent or assistant. The days of week, we can choose one day among the days, Monday, Tuesday, Wednesday and etc. Like that, we can choose this one out of the same type. And I have given the general format of writing the case statements in pseudocode algorithms. We have to use case of keyword in here before give the expression. Then from the next line, we have to write condition colon the statements to be evaluated if the condition is true. Finally, with the others keyword, we have to give the default statement that have to be executed if all of the above conditions are false. This will execute only above conditions are false, the others statement. like else part in the if else if structure. In here others part is acting. Then end the case structure by the keyword end case. In here others clause with its default statement is optional. If you have given all the possible conditions above, you don't have to give the others part. You can ignore that. And normally conditions are numbers and characters. Here is a simple example for case statements. We have to give the grades according to the points. So we can begin by the keyword case of, then the expression is grade. A4 points equal 4, B4 points equal 3, C4 points equal 2, D4 points equal 1 and F4 points equal 0. You can see we can write it as first condition colon statement that must be give if the condition is true. Then the second condition and colon statement that must be give if the condition is true, like that. And finally end the case statements by using the keyword end case. You can see I have not given the default statement in here, right? Because I have stated all the possible conditions above. Then I ignored the others part. Okay, those all are about selection structures. Now we will see what are the repetition structures. Repetition structures. This is also known as looping or as iteration structures in the programming. Repetition structures allow us to repeatedly process one or more statements until some condition is met. Mainly there are three repetition structures in programming. First one is while, second one is for, and the last one is do while. Those all are conditional statements. According to the conditions, program flow is happening. Now we will see each of the repetition structures one by one in detail. First one is while loop. While loop is repeatedly executes as far as the given condition is true. When the condition is false, loop breaks. It means we can repeat an instruction or set of instructions according to the condition repeatedly in here. I have given the general format for the pseudocode algorithms in here. We can start with the keyword while, and we have to give the condition that must be true for the execute statements. Then the next line, the statements that must be repeat, and after that we have to finish the loop by giving the keyword and while. I have given a simple example for while loop in this slide. It will display the counter until the counter is less than or equal to 10. It means it wants to print the numbers 1, 2, 3, 4 until the 10. For that, first we have to initiate the counter variable. In here count equal 1. It means display will start from the number 1. Then we have to write the while loop. First while keyword, then the condition in the brackets, counter must be less than or equal to 10. It means this loop won't be repeat until the condition is false, until it will be 10. We called it as termination condition. Then we want to display the numbers, display counter. Then the step up condition, count equal count plus 1. It means in every iteration count variable must be increased by 1. Finally, we have to finish the while loop by end while keyword. And now we will trace this and see how it works. In the first time, count equal 1. Then 1 is less than or equal to 10. 1 is less than 10. Then display 1. Then now count is 1. 1 plus 1 equal to 2. Now the count variable is 2. Then again check the condition. 2 is less than 10. Then display 2. Then again counter variable is 2. 2 plus 1. Now count variable is 3. Next again check the condition. 3 is less than 10 and display 3. Like that it will continue until count is 10, until display the 10. After display the 10, counter is 10. 10 plus 1, now count is 11. 11 is greater than 10. Now loop is breaks. That condition is false. In here minimum iteration is 0 because the condition is checked first, and if the condition is not satisfied, loop will not execute. Think initialization count is 15. It means in here count equal 15. Then 15 is greater than 10. So while loop will not execute. I think you have understood what is happening inside of the while loop. Then the second repetition structure is for loop. Same purpose as the while loop. For loop enables a particular set of conditions to be executed repeatedly. A condition is satisfied. All the while loops can be written as the for loops, and all the for loops can be written as the while loop. You can use either for or while, both the same. In here I have given the general format for writing the pseudocode algorithms using for loops. First, the keyword for, the conditions must be satisfied. Then the next line, statement or statements that must be executed iteratively until the condition is false. Finally, finish the for loop by end for keyword. Again, I have given the same example that I have discussed with you in the while loop. For loop to display the numbers 1 to 10. First the keyword for, then initialization, counter start at 1. Then the termination condition in middle, counter less than or equal to 10. At last, step up condition, increment counter. In order of initialization, termination and step up condition is have to follow. You cannot change the order. First initialization condition where we must be start, and the second termination condition where we have to stop the iteration, and the third step up from how much we have to increase at once. Then the statements that executes if all the above conditions must be evaluated to true and display the number. Finally, finish the loop by end for. Here also minimum iteration is 0 because it checks the condition, and if they are true only statements are executed, otherwise loop is skipped by the algorithm procedure. Now we will trace and see how it works. In here, first counter start with 1, then check the condition 1 is less than 10, then jump to the statement display the number, it means display 1, then jump to the increment counter, increment by 1, then again go check the condition, now count is 2, 2 is less than 10, then again display the number, and again go to the step up condition, increment counter, now count value is 3, 3 is less than 10, again display the number 3, like that until 10 it will work. After that, when displaying the 10, increment the counter, 10 plus 1, 11, 11 is greater than 10, then loop is closed. In here, the very first time only checks the initialization. So I think you got an idea about how for loop works. Now we will move to the do while loop. Do while loop is similar to the while loop, but there is one difference. In here we are given the conditions at the last, so the body of the do while loop is executed at least once and then check the conditions. So in here minimum number of iterations are equal to 1 because it executes once and check the conditions. Every do while loop can be written as while loop, but you cannot write every while loop as do while loop because the while loop with 0 iterations, it means which conditions is false at the beginning, cannot replace by the do while loop. Do while definitely execute once if the condition is true or false. In here I have give the general format for pseudocode writing in the for the do while loop. First, beginning with the keyword do, then the statements that want to be executed. In the next line, while keyword and the conditions that must be satisfied. And another speciality in here, if you notify in every other structures, we have to use end keyword with the structure name to indicate that we have finished the writing of that structure. But in here, do while, we are not using that keywords, just write in the while and the conditions only. Same example I implemented in here also. Display the counter until the counter is less than or equal to 10. Same as the while loops, it start with this iteration initialization condition count equal 1. Then the next line do keyword. Then the statement that we want to repeat. Then next step up condition count equal count plus 1. After that, at last while keyword with the condition count is less than or equal to 10. This is same as the while loop, only difference is starting with the do keyword instead of while keyword and the condition, and at last instead of end while keyword we have to use while and the condition. Now we will trace and see how it works. First, count is equal to 1, then display the counter, it means display 1, then 1 plus 1 equal to 2, now count is 2, then check the condition, 2 is less than 10, then again go to the do part, display counter means display 2, now 2 plus 1 equal to 3, count is 3, check the condition, 3 is less than or equal to 10, again display the counter. Like that it will goes until 10. When after displaying the 10, count equal 10 plus 1 means count is 11. 11 is greater than 10. Now loop breaks. Okay, now you all have an idea about repetition structures. There are a few more things about pseudocode algorithms. Let's see those. Indentation. I have talked about this in the if-else if slide also. When we are writing algorithms, indentation is important. Indentation is aligning statements in a logical manner, or we can say logical flow. Pseudocode saves the time later during the coding and the testing stage, so it must be clearly readable. For example, align statement inside an if statement into the same level. You can see if and end if keywords are in the same level and the statements are in the another same level. It is clear, easily readable and understandable by anyone. Like that, in every structure in the pseudocode must follow the indentation, and indentation improves readability. Then few more important facts about algorithms. Algorithms must arrive at the correct solution within a finite time, and it must be clear, precise and unambiguous. Then it must follow indentation, not contain full sentences, just keep keywords and shorten. And it must be format which can be implemented in the programming language. Okay, those are the things that you want to know about algorithms. From today's lecture, you have learned about arithmetic, relational and logical operators, use of them in the control structures, and tree control structures, sequential selection and repetition. In selection, if statements, if else statements, nested if else statements, if else if statements, and case structure. In repetition, while, for, and do while. So I have covered all the fundamental things about the algorithms in the last lecture and this lecture. Now you have to practice those things for writing algorithms, because after reopen the university we will start the practical sessions, codings for solving the problems. Before coding you have to know how to write algorithms for each problem, so keep practicing. And also I have uploaded a worksheet for this lecture also. Find it in the PDF version of this lecture. If you have any question, you can email me. I have given my email address in the first slide. Thank you.